Hi, today we'll create an agentic application in LangChain4j and Spring Boot. I called this application CodeSparks. So what is it? Imagine you're a technical recruiter and you have an interview in a few minutes. What questions will you ask? You spot a candidate's GitHub on the CV and find an active side project there. Use CodeSparks and in a moment you have a number of questions and talking points. So let me start the project and show you how it works exactly. Okay, it started, and in Postman I have a request prepared. We will be requesting two questions about the public repository on GitHub Spring Pet Clinic. I clicked the send button and in a few seconds we should see two questions. And we have it. We have a brief description of what is pet clinic. And we have question number 2 with code samples. This question is about. And question number 2 also with code samples. So that's CodeSparks. What does the application actually do? First, it clones a GitHub repository, then an agent inspects it, and finally it returns a number of questions. So the tech stack. The tech stack is Spring Boot 4.1, LangChain4j Agentic, which is still an experimental module, JGit for cloning GitHub repositories, and we'll also spin up a local MCP server called server-filesystem by Anthropic. This MCP server will provide tools for our agent, tools like reading text files, listing directories, searching files. And to spin up this MCP server, you will have to have Node.js installed on the system. Agent versus agentic workflow. What is the difference? On the right, you can see the definitions, and let's read them now. Workflows are systems where LLMs and tools are orchestrated through predefined code paths. If there is a predefined code path, it's a workflow. Here you can see a workflow example, a sequential workflow. This is just a chain of LLM calls, which finally gives some output. If you want to know more about different workflow patterns, you can check the LangChain4j documentation and check loop workflow, sequential workflow, parallel workflow, conditional workflow, or read the Building Effective Agents article. Okay, agents. Agents are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. An agent will be given a task. An agent will have a set of tools available. It will most often decide to use some tool, get a feedback, reason about it, decide to use some other tool, get a feedback, and maybe then it will decide to provide a final answer. What we will build? We'll build a sequential workflow. First, we'll clone the GitHub repository. This is a non-LLM step, and then the InspectCodeAgent will use the tools provided by the local MCP server to inspect the cloned repository. Finally, we'll get an answer, and this answer will be a few questions a technical recruiter could actually ask the interviewee. Here you can see the workflow, and inside the workflow we've got an agent. One thing which is worth knowing is the agentic scope. So agentic scope is something introduced by LangChain4j Agentic, and it's simply a collection of data shared among the agents. If we had another agent here, it could potentially read the output of the InspectCodeAgent. Okay, so it's time to create the project. let's do it with Spring Initializer Web. The project will be in Maven, language Java, Spring Boot 4.1.0. The group will be com.codesparks. Artifact will be called codesparks. And let's make the package name shorter. Package jar configuration properties. Okay, and Java 25. Dependencies. I will just need the Spring Web dependency. And we are ready to go. Generate. We've got an empty application. Let's start with the dependencies. First, let's find JGit. Okay, I'll copy it and add this dependency. Refresh Maven. Next, let's add some LangChain dependencies. Here in the tutorial section, you've got Spring Boot integration, and we've got Spring Boot 4. So let's copy it. And let's create a property with the LangChain version. And use it here. We also get the properties. We can copy to the application properties. Let's copy it. And here you can see that we've got model API key. And this application expects that we've got OpenAI API key environment variable with the OpenAI API key. The model, it says GPT 4.0, but I would like to make it 5.4 mini. And in IntelliJ Ultimate, to set this environment variable, you can edit the configuration and find environment variables. Here you would add this OpenAI API key and paste the value you have from OpenAI. I will do it outside the camera. What else do we need? We've got the main dependency, but we will also need the Agentic dependency and the dependency for the MCP server for the client. So I have it prepared. Just paste it. LangChain4j Agentic, LangChain4j MCP. Okay, let's check if Maven will sync everything for us. Okay, outside the camera, I've set the OpenAPI API key environment variable. Now let's check whether the application starts. And it does. Can start implementing. I will start with the Git service for cloning GitHub repositories, and the service will also have a cleanup method. Let me Ctrl-C, Ctrl-V, the implementation of this class, because that's not really that important here, but I will go through it. We'll be cloning to the CloneRepoAgent directory, which I will now create inside our own project. CloneRepoAgent, of course. This clone repository gets repository URL and outputs the absolute path to the cloned repositories. Okay, and the cleanup will just clean up everything from the cloned repositories directory. We've got file system utils, delete recursively everything from the base directory, which is cloned repositories. Okay, we can start implementing the agents. I will start with the CloneRepoAgent. And this is the non-LLM step. It will be a class, not an interface. Add component. And we'll be needing the Git service. And here we have it. Right now, let's write the clone repository method. And first, LangChain4j annotation at W. This annotation will get the variable called repository URL from the Agentic scope. How to set it in the Agentic scope, I will show you when we start implementing the sequential workflow. First, I will do the cleanup, make sure that, well, the cloned repositories is clean, and only then I will clone the repository. And this method returns the absolute path to cloned repositories. Okay, to really make it an agent, we have to put the agent annotation. With value, we give the description of the agent. This agent clones a Git repository from the given repository URL and returns its absolute path. Okay. And this agent will output the repo path. All right, we can start working on the MCP server. So let's check the documentation. What we ultimately need is MCP tool provider. This will be providing tools for our agent, but to create it, we will need MCP transport and MCP client. there are a few different types of MCP transport: standard input-output, streamable, WebSocket, HTTP MCP transport, but we will need the first one, standard input-output. And this example shows how to start a server from an npm package as a sub-process. I will just copy it and let's start create some beans. First, new package. Let's call it MCP. And inside MCP, I will create the MCP config class. So it will be a configuration. The first bean we need is MCP client. Okay, the imports. And in the command, we put what we would like to start. And we would like to start npx with the -y to say yes to any questions which could arise during the execution of this command. And our server, MCP server name is server-filesystem. There is one more thing we have to do. We have to allow the server file system to access this cloned repositories. So this will be put here. System get property user.dir will give us the path to place from where the JVM started. And I will add the /cloned repositories. Okay, do we want to log events? True. Yes, we want to log events. Okay, we wanted MCP client. Let's check the docs. And let's copy it. I don't think that we'll need key. And we've got the first bean. Okay, it's time to create the MCP tool provider from the client. Another bean, returning MCP tool provider. And this needs MCP client. And we will be returning it. Okay, we have it. One problem is that the MCP tool provider will provide us with all of the tools provided by the server file system, but maybe we don't need it, or maybe we don't want it. Let's check the tools provided by the server file system, and I will do it in the main application class just by creating the command line runner bean. So this will be executed on the start of the, after the application has started immediately. Command line runner. The method name log MCP tools. And we'll need MCP client to check the tool names. print available MCP tools. And the MCP client has a list tools method, but to print it in a nicer way, I will iterate over the tool specifications. Tool.name and maybe also tool.description. Okay, let's check what tools are available by running the application. Available MCP tools: read file, read text file, read media file, read multiple files, write file, edit file. So we've got some tools which edits things, and I don't really want tools which edit anything. I will just restrict what tools will be provided, and this is done by the filter tool names method. What do we want there? This method is deprecated, so I will not put it, but read text file. Read multiple files. List directory. It's okay. Directory 3 and search files. Get file info, not necessarily list allowed directories. We don't have to have it. Okay, let's run the application again. Oh, we still have all available tools. But that should be okay with the filter tool names. Now it's the time to implement the InspectCodeAgent. And this is an LLM step, so we'll do it by creating an interface. I'll just copy paste the content and explain what's going on. We've got a method and the parameters are repo path and number of questions with the @w annotation. @w says that it will be taken from the agentic scope, so from a place to which all agents have access. We'll need repo path and the number of questions because we want the InspectCodeAgent to inspect this repo and provide us with this many questions. And we also have system message and user message annotations. System message basically tells the agent who he is, and we want expert software developer working for a technical recruiter. In the user message, we tell it what exactly it should do. First, we want to describe what the project is, what it tries to solve. We want X number of questions, and that these questions should help the technical recruiter to judge the level of the interviewee. Junior, mid, senior. We give it the repository path, and we tell it to attach code samples on which the questions will be based, but only when it makes sense. And here it's got an example of the code sample. Okay, so got the interface, but that's not all. Oh, we also have an agent annotation, which just describes the agent. And except the interface, we will also need to create a bean. Let's create another class and call it agents config. And this will be a configuration class. We need a bean, and it will return the InspectCodeAgent. Oh, typo. Let's fix it. So to create an agent, we'll use Agentic services class from LangChain4j and the method agent builder. And we'll give it the interface. We'll also need the chat model. We'll also need the tool provider. And we don't want the agent to do infinite tool calling, so we'll restrict it to 10 tool calls. In the application properties, we've got the LangChain4j OpenAPI chat model name. So we'll have this model automatically configured. We can just inject it. And not only the chat model, but we also inject the CP tool provider. Okay, can just put it here. The InspectCodeAgent will produce some answer. We want to have access to what it produces. We'll give it a name, answer. Okay, we have defined the InspectCodeAgent. Now let's create the workflow. We'll be creating the workflow, but in LangChain4j code, everything is an agent. We'll be returning untype agent. And I will call it main agent because that's what we'll be using in the controller. As you can see, we have just created the InspectCodeAgent bean, but we haven't created the CloneRepoAgent. That's because this is non-LLM step. That's not an interface, it's a class. And we have the add component annotation. we will need both of those agents. And we'll use Agentic services to create a sequential workflow sequence builder. And we will create an instance of onTypeAgent class. We have to give it the agents. So first the CloneRepoAgent and then InspectCodeAgent, and we can build the workflow. Let me show the documentation. So we've got the untyped agent here. That's one way of creating such an agent. But then when you call the invoke method, you have to call the invoke method and give it a map with the parameters. So that's not very nice. And we can create a typed agent. In this case, the untyped agent interface can be replaced with a more specific one like this. That's what I will do. Let's create the main agent interface. And in the main agent, we have to create a method. So this will be our main entry. And if you can remember, we need a repository URL. And we also need the number of questions. And this is the place when we first put the repository URL and number of questions in the agentic scope, when we will invoke the analyze repo method. This will be an int, and this will be a string, of course. And we also need an agent annotation. We don't have to put the description here. And we can change this untyped agent to be the main agent. We have the main agent, which is our sequential workflow. Oh, and one more thing. We need the output key if we want to get anything. We seem to have everything. We need something to test our sequential workflow. Let me create the web package and a controller. The controller will be named analyze. And I will copy paste the analyze controller. We have the /API/analyze post controller. I set the default number of questions to 5. We inject the main agent. And in the post mapping, we have the request body with the repository URL and number of questions. First, we set the number of questions. If it's available, we take it from the request. If not, we default to the 5. And we just call the analyze repo method on the main agent with URL and number of questions. Let's check if it works. The application starts. Postman. I have prepared the post request here, and the repository URL is Spring Pet Clinic. It's a public repository on GitHub. Okay, let's check it. Send. This will take a few seconds. Let's check the logs. And in the logs, you can see that the agent is using tools like search files, like directory tree, list directory, read multiple files. And we have an answer. Okay, we get a brief description. This is Spring Pet Clinic, a Spring Boot web application. And we have 2 questions to judge the level. Question number 1. The LLM tells us why this question helps. Assess the level. It tells us what the junior can explain, what the mid can explain, and what senior should tell. And we get a piece of relevant code. And we get question number 2. If you want, you can check it on one of your public GitHub repositories, but for now, I would call it a great success. Before wrapping up, let's fix one small thing and talk about the flow of data between the agents. One small thing is that we now have this cloned repository inside our CodeSparks application. And if we are going to develop CodeSparks, it's good to add the cloned repositories directory to the git ignore file. Okay, done. Okay, so the journey starts from the post controller. We have the main agent, and we call the analyze repo method with the repository URL and number of questions. The main agent gets repository URL and number of questions from the Agentic scope. The main agent represents our sequential workflow because we've got sequence builder and sub-agents. So the first real step is CloneRepoAgent, and it's a class, not an interface, because we are implementing something here. Here we are calling the cleanup method and the clone repository with the repository URL, which we take from the Agentic scope, which was set by the previous step. And this whole clone repository writes into the Agentic scope repo path. We return the repository path here. And finally, we've got the InspectCodeAgent, which reads this repo path from the Agentic scope. And the InspectCodeAgent finally returns an output. That's the whole journey of the data.